We started today's class with a really nice discussion on how we actually approach this, and these were 3 comments that came from grading your quizzes. So the key, when I have something here other than just plain x, so for example, here we have x plus 3. On the quiz, it was x minus 4. It could have been a number like -2. If there's anything here other than just a plain x, we really need to have this thought in mind. How do I rewrite this? What do I do first? And then what do I do with what I get? So we agreed at the start that right away we can write this as h of g of x plus 3. And again, the big idea here is that because we have something other than just a plain x right there, there is something we can do. So off to the side, let's work on g of x plus 3, which will become 5 times x plus 3 minus 1. And there was a consensus on that. So that's 5x plus 15 minus 1 is 5x plus 14. So by means of these 2 pieces, we've answered, how do I rewrite this? And what do I do first? What we did first was the middle, dealt with what was on the inside, because we could. The third and most important question when it comes to the algebra is, what do I do with what I get? So now we know we can rewrite this as h of 5x plus 14. What's my guide going to be? What function am I going to look at? H. So if it helps, because this did happen to a couple people, when you see that you're dealing with a quadratic or something that's a little bit longer, go ahead and rewrite h. So h of x equals what? Minus 3x minus 10? Okay, so this is going to be my guide. So now h of 5x plus 14 becomes 4 times 5x plus 14 minus what? Yeah, this second substitution, about 3 or 4 people dropped it by accident, and it caused the rest to be no good. Like they worked with this well, but then they dropped this. So again, if we're working with something longer, write it out. It'll be your guide. What should I do first? Exponents. So just like we did this off to the side, let's work with 5x plus 14 all squared off to the side. I would say this was about half of you guys struggled with what this means. What does this mean? Yes. I had some interesting answers on that. Okay, so if we got it wrong on the quiz, let's make sure we get it right here. What do I do first? So 5x times 5x is 25x squared, and then 5x, that's supposed to be a 14 over there. 5x times 14? Now we'll send in our 14. 14 times 5x? 70x again. And 14 times 14? 196? Just going to move this over. What can I do? Yep. We need a little more space. I add 70 and 70. And we get 25x squared plus 140x. It is much easier to deal with this on the side than trying to work on it in here. Now we're just going to pull our result in. So this becomes 4 times what you just found off to the side. 25x squared plus 140x plus 196. And then what can I do with this 3? Yes, so that becomes, so that also happened. Some people, when you were working, and if I saw this, I tried to point it out to you, you forgot to use these parentheses. And why are parentheses important right there? We're distributing a what? A negative. So now when I distribute that negative 3, I'm going to get minus 15x minus 12 minus 10.
Wait, no, it's 14, right? It's 5x plus 14.
3 times 4?
It's supposed to be 14.
Oh, thank you. Yes, drop the 1. Okay, let's try that again. Negative 3 times 14? Okay, let's distribute 4. So as crazy as this looks, this is just algebra. So when we're dealing with big numbers, if you want to check you're doing 3-digit multiplication, by all means, go ahead and use a calculator. We all know 4 times 25, 100x squared, yep. And then 4 times 140x, 4 times 196. Can bring down that minus 15x. What is negative 42 minus 10? If you chose to do it right here. Awesome. And now we just need to combine like terms. Where do we have like terms? Yep, and when you box like terms, make sure we include the sign in the box. Very good. So when I combine these like terms, we get 100x squared 540 plus 545x. That's it. So whoever got the stamp on their own, come on up. Otherwise, use this as notes to help you fix that quiz question. Yep.
I just like to pull it.
So today we are moving on. We're done with function composition. How did last night's homework go? With these notes, are there some that need to be fixed? Because I will be looking at accuracy for some of these questions. And I do know that it was a meaty practice. It was a pretty intense practice. Tonight's homework will not take you that long. If I give you one more night, will you fix what's possibly wrong? All right, we'll do that. I'm fine with that. Only because I saw so many struggles on the quiz on this piece, and now with these 3 thoughts in mind, when we have something other than X, I think we can go back and make some adjustments. So if you didn't write these 3 questions down, you might want to put them at the top of last night's homework or on your stamp question that you'll use for notes. But whenever we do not have X as an input, if I have X plus 3 or 5 or negative 8, we always want to ask, how do I rewrite this? What do I do first and do it off to the side? And then what do I do with what I get? Jasmine and Michelle are passing out what we're about to do in a couple minutes. We are going to start with board notes. So when you're ready, let's start on a nice fresh page. Today's date, title 1.3, Piecewise function. 1.3 piecewise functions. Today is Tuesday. (9:27). Officially the start of 1.3 piecewise. Say that again? Yes, I'll clear the wall. We'll do that after. Thank you. Piecewise functions. The smartboard is being a little funky right now, so if some letters come out weird, like that's supposed to be a U function. If there's letters that aren't coming out right, let me know. If you can't figure out what it is, I'll definitely just erase the whole thing and start over. A piecewise defined function. What is a piece? What does it mean for something to be a piece? It's a part of a whole. That's exactly what we're going to be looking at when we talk about piecewise functions. So our definition for piecewise defined function is going to be a function who is composed which means made up of, unofficially, but composed is a much nicer way of saying it, made up of multiple equations. Multiple equations. Each piece corresponding to a part of the domain. A function who is composed or made up of multiple equations, each piece corresponding to a part of the domain. Yes? Say that one more time.
Why did it say who instead of that?
Write whatever word makes you happy. Could be either. You could say who, which, that. It's got a personality. It's cool. It's made up of pieces. Let's make it a person. But if it makes us feel better, I have no problem making it that. Better? Better? Okay. A function that is composed or made up of multiple equations, each piece corresponding to a part of the domain. So let's look at our exploration that was passed out by Michelle and Jasmine. And this is our first example of what a piecewise function looks like. We're going to come back to our board notes in a moment, but let's dig into this exploration a little bit. So I will come back to this page in a moment. Piecewise functions assign different rules to different inputs. So for example, if we look at 2x plus 1, what rule applies to 2x plus 1? Straight across, what does it say? Right, so that's what we mean by rules. This rule for x applies to this piece. What applies to x squared? So yes, we technically could read this from the left. How would I read this from the middle? X is greater than or equal to -2 and less than 2. Or you could see X is between these two values. And then what rule applies to -x plus 6? Yes, so that's what we mean by rules. Good. So consider the piecewise function below and its corresponding graph. Note that the inequalities tell you which part, this is key. From now on, the highlighters will be on that cart when you first come in, so if you don't have your own, you can always pick one up. This is the key. The inequalities tell you which part of the domain is used for each rule. So notice how number 1 says, find f of -4 and identify this ordered pair on the graph. Can I find f of -4 without the graph? Interesting question. Let me say it again. Can we find f of -4 without the graph? How, for those of you saying yes, how would you figure that out?
Can't you make like the 2x plus 1, like that whole part, like an equation?
So she's saying we should be using this first rule right here, 2x plus 1. Is she right? Why is she saying it's 2x plus 1 that we could use? I can't use the whole thing. I had to choose this one, or this one. How do I know which one of these applies to f of -4? Then? Did you all hear him? No. Say it nice and loud, because you're absolutely right. The rule here is when x is less than -2, which function am I using? Very good. So let me say that again. This is key. We're asked to find f of -4. When I look at these inequalities, -4 is less than -2. Therefore, I know to use 2x plus 1. So let's find f of -4. What would that be? 2 times -4 plus 1. What do we get when we do that? -8 plus 1, -7. So this says when x is -4, y is -7. Is that true? -4, 1, 2, 3, 4, 5, 6, 7. Try f of -1 on your own. Which rule applies to the input -1? Where does -1 fall? Who knows where -1 falls? First, second, or third? Very good. Why the second? Yes. -1 for x values falls in between -2 and 2. Nice job. So now we know we're using our second one. So f of -1 would be -1 squared, which equals 1. Did you successfully find that point on the graph? What would the ordered pair be from the algebra that we're seeing? Say it again. When x is -1, what did you get for y? 1. So let's see. -1, 1. Check. Plus or minus comes from when we take the square root. But squaring a value will always get positive. Nice job. Let's work on number 3. So the question doesn't change. Where does 3 fall in these rules, in these inequalities? Is 3 less than -2? No. Is 3 between -2 and 2? No. Is 3 greater than or equal to 2? Yes, it is. So which rule do I use? This third one. you guys get? From the algebra, what ordered pair should this be on my graph? 3, 3. Let's go look. Are we right? 3, 3. What are we thinking about f of 10? I mean, if I look, do you have 10 as an x value? No. So now we definitely can't use the graph. But f of 10 does exist. How are we going to figure that out? Which rule applies? How do you know it's the third one? Because 10 is definitely greater than or equal to 2, which means I will be using negative x plus 6. So let's find that. F of 10 will be negative with 10 plugged in plus 6, which is negative 4, and we're done. Domain and range of this one is going to be awesome. Let's go look. Okay, so remember that we do have an arrow here. I know we made that point clear on the graph, but this is an arrow. So just look first for domain. Let your eye go from the left and make its way over. What might be an issue? Where might we have a hole? Negative 2. But then if I look, is it filled in? Remember that conversation that if I have a hole, but I have another x equals negative 2 that's solid, this solid dot fills in the empty one. So that's not a problem. We're still okay. Keep going, keep going. Any problems? No. So what's my domain? You can say all real numbers, negative infinity to infinity, whatever makes you happy. I don't like that R. Start looking at the range. Coming from the bottom, coming from the top. What are we thinking for range? So I agree, we come from the bottom. I have negative infinity up to negative 3. Now I definitely have a jump, right? There's no graph here. But, there's an arrow. This arrow is going to keep going what? So eventually, is it going to fill in that gap? Yes, it is. So do we actually have any holes to be worried about? Nope. It is not, though. It is not negative infinity to infinity. So I still agree with the negative infinity piece. But it does end at 4 when I come in from the top. Very good. So my range will be negative infinity to 4. Come on, wasn't that fun? That was such a cool graph. I think so. I think it's cool for everybody. All right, negative infinity to 4. Awesome. Let's go back to our board notes. And let's look at an example completely without a graph. So the example is f of x equals. So to write a piecewise function, we draw a big bracket. There's going to be 3 rules associated with this piecewise function. So mentally space out a first, a second, and a third line. First line, 3/4 x plus 2 when x is greater than or equal to 8. Second rule, f of x equals 5 when x is between 4 and 8, when x is strictly greater than 4 and strictly less than 8. And our third rule, negative 1/2 x + 3 when x is less than or equal to 4. Yes. Does there? Ooh. Think of what the graph. Hold on, let me write this, and then we'll talk about that. So the question was, does there need to be an x here? Blast from the past. F of x equals 5. What kind of line is that? It is constant. What special case is it? Very good. Horizontal line going through 5. So great question. So the answer to that is no, it's a constant horizontal line. F of 6. Where does 6 fall? The first one? 6 is greater than or equal to 8? Nope. The second one? How do you know? So what's my answer? It's that constant function, right? No matter what x value you go to, you'll be coming up to that horizontal line. Very good. Very good. We definitely have a couple minutes. So I'm going to have you get started on the homework. It's going to use the same concepts we just talked about. Remember, sometimes the announcements are early, so even if announcements start, we're definitely going to work straight to the bell because I want to make sure you leave here today comfortable with this. So at least be able to try 4 or 5 of these before we go. You're welcome. Here we go. Let's get started. Solid 6 minutes. Be working with a partner. You should be getting the same answers. Yes, very good. So letters matter here. Number 1, what function are you working with? Which function? F, G, H, or J? F. So just F.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Let's take a seat. Make sure you can at least do 3 or 4 before we go. We have time.
Have a day of excellence.
So ask ourselves, where does 2 fall into these rules? Yes. Questions? I have a whole box right up there. Yes. Yes, I'll write your pass. Is a question? Yes, I can sign it again. Let me just write him a pass. Any questions, let me know. Someone else might have the same question. So for number 1, we're dealing with 2 as an input, right? So ask yourself, is 2 less than or equal to 0? No. Is 2 greater than 0? Yes. Got it? So every input, once you identify which function you're using, almost like do a check, like a mental check. Where does that input fall in the restrictions? And that will tell you which function you're going to go use. All right? Great question. I'm all ears for questions. So any doubts, let me know. Nicole, you good? So for example, number 1 says f of 2, yes? So which of these functions are we using? You good?
Yeah, I was looking at this only.
Okay, yeah. So we have, it's almost like a bank of 4 piecewise functions. You good?
Yeah.
All right. Jasmine, you good? Jasmine. Yes. No, didn't ask you for it. So you're good. Just the value. Yes. Correct. Yep. If I had x involved somewhere, that would involve more work. But this would be a constant function, a horizontal line going through where? The y-axis at what value? Yes. Very good. So what that means is literally imagine it. No matter what x value you have for that piece, it's always going to go up to the same y value. That's what creates that horizontal line. Good questions. Keep the questions coming.
Is this right to the class?
Yes. Yes. Careful. 1/2 is less than 0.
Oh.
Questions? How are we doing? How are we doing?
Fine.
Great. These are like a function bank, right? So any that starts with an f of anything, we're referencing this. Correct? Yep. That's it. That's like that special case. Well, right. So here we're in that special case, like up right there, right? 5, that question, doesn't it have to have an x? And the answer is no, because, right, because those are special horizontal lines. So don't overthink. This entire top row, there's going to be no math involved. In the others, correct, because x is present. So we'll actually have something to plug into to find a value. How are we doing? Nice. Looks good. Very good. Nice job. See you tomorrow. We'll check answers first thing. The type 3 will be collected first thing tomorrow morning. So if you have any questions, please send me a question on Remind, and I will help you with that. So 2 assignments due tomorrow. The type 3, the independent practice type 3, and tonight's Piecewise function evaluating worksheet. Have a great day.